What is up, everyone? We're doing skill practice 43. Yeah. Keep in mind, I do talk a little bit slow, so do take advantage of the speed up playback, like times 2 speed. Yeah, so adjust the video to your liking. Yeah, so let's get into it. A. What is the order? What is the order with respect to ClO2 in this reaction? So when it says with respect to, thank you, Karen, for helping me out on this one. It means that we want to find out where we need to find out the differences in ClO2. But how we do that is by looking at the iodine, and seeing like which ones are the same, which one are constant. So we see that 0.4 and 0.4, right? These two are the same. So reactions 1 and 2 are the same. So we need to look at those for ClO2. So for ClO2, it's 0.3. The change is 0.3 and 0.9. And so this change, 0.9 divided by 0.3 is 3. And then 9.045 times 10 to the minus third divided by 3.350 times 10 to the minus 4. This will give you 9. This will give you 27. And the way to do rate law practices is that to find x, it's always exponential. So it's 3 to the x equals 27. And so you solve this by seeing 3 times to what power gives you 27. And so that will give you x equals 3. Right, so it's a third order. So I'm gonna put my answers right here. So 1A will be 3. B. Alright, let's go to B. What is the order with respect to I in this reaction? So I is right here in this column. And so what we need to find out is we need to pay attention to ClO2. And the way we do that is we need to find out which ones are constant in this one. So we have 0.3 and 0.3. Those are constant. So we need to look at experiments 1 and 3, right? So looking at experiments 1 and 3, we have 0.8 and 0.4. The difference, like the change, is 2. Because 0.8 divided by 0.4 will give you 2. And 5.360 times 10 to the minus third divided by 3.350 times 10 to the minus 4 will give you 16. Right? And then since it's always exponential, we put an x right here. And so 2 to the x pot, what will give you 16? And this will be 4. So B is 4. Alright, so C. What is the overall order in this reaction? So overall order is you just add the orders together. So 3 and 4 will give you 7. So that's the overall order. So write the rate law for this reaction. So the rate law, right, the rate equation is what's going to be rate equals K. And then what goes right here will be the reactants. So the reactants, we have ClO2 and I. You want to draw brackets around both of them. And then since they're both to the power, right, because rate law always deals with power, ClO2, right, for A, it says what is the order with respect to ClO2. We found out it was to the third order, so we put a 3 up here. And then for B, what is the order with respect to I? We found out it was 4, so we put a 4 up here. And so we have this equation, right? And so to find, so this is going to be the rate law, right? This is just shear rate law. D rate equals K ClO3 3 I 4. And so it says D calculate the rate constant and include the units. So to find the rate constant, we just plug things in, right? The rate will just be anything in this column. CLO 2, anything in this column. I, anything in this column. But there's one note. It has to be the same experiment. So let's just use number 2, for example, right? The rate is 9.045 times 10 to the minus third. Molarity over seconds equals K constant. ClO2 is 0.9. And don't forget the cube, the third order. And iodine, which is 0.4. To the fourth power. So, I forgot one thing. I forgot to add this M. Because these are all molarity. These are all like concentrations. Because right when it's brackets, it's always concentration. It's molarity cubed. And iodine is gonna be 0.4 molarity to the fourth power. Right. So 0.9 M cubed is going to be so the third order is going to be 0.729 M cubed, and then 0.4 cubed is going to be 0.064 M to the fourth power. Right. Okay. Let me just bring this down, right? We keep things consistent. So 9.045 times 10 to the minus third. Right? Okay. So what we do is we divide both sides by this number. So 0.729 times 0.064. This will give you 0.46565. 6656 M to the 7th, right? You always have to divide it by the M to the 7 because 3 plus 4 is 7, right? M3 plus M4 is M7. And so the M7 have to cancel out in order to isolate this K. So divide this side by 0.046656 M to the 7, right? I forgot to bring this down, so it's M over S. Hopefully you guys can still see that. Yeah, M over S. And then K will equal, right? You divide 9.045 times 10 to the minus third divided by the 0.046656. It will give you 0.19. Okay. Why isn't this right? I made a mistake. Sorry about that. I did 0.4 M to the 4. M to the 4 won't be 0.064. It will actually be 0.0256. Right. So this will be instead be 0.0186624. Yeah, same thing right here. 0.0186624. Right, and so your K will end up being 0.048. And now for the units, right? If you look right here, right, it's M over S all over M to the 7. And write a little bigger over here. M over S all over M to the 7. So this is basically, right, M over M to the 7 S. Because, well, I can teach you the math right now. I'll just teach you right now. But like, if you don't, it doesn't really matter. But like, over m to the 7. This is a, right? In order to bring this m to the 7 up here, you divide it by 1 over m to the 7. These cancel out, and 1 over m to the 7. Right, because whatever you do to the denominator, you also do to the numerator. And that's why you get m over m7 over s. And then these cancel out, right? M to the 1 over m to the 7. This will give you m to the 6. So this will give you 0.048 1 over m to the 6 s. Alright, I made one more mistake again. I forgot to put parentheses, and so this should be 0.48. Yeah, I'll just do it right now, right in front of you. 9.045 times 10 to the minus 7, or minus 3. Right, divided by 0.1866 0.0 0.1866. This is gonna be a long video. I know it is. Okay. Right. I get 9.045, and then divided by 0.0, and this will give you 0.48. Yeah, so 0.48 1 over m to the 6 s. Okay, cool. Now f. How does the rate of disappearance in ClO2 compare to the rate of disappearance in I2? And so, the rate of disappearance for ClO2 is right here, because disappearance is in reactants, and the appearance of I2 is right here. And so it's just like the same thing in skill practice 42. It's just it's just ratio, right? 2 to 1, because right, there's the coefficient of 2, coefficient of 1. So just 2 to 1. Boom. All right, on to number 2. Okay, so number 2. What is the order for each reactant? So let's do it for H2O2. Right, so we need to find, when we're doing it with respect to H2O2, we need to find an iodine and an H that are both constant in here, so that are both the same. So automatically I see that experiments 1 and 2 work, because like 0.010, 0.010, that's the same. 0.5, 0.75, those work. So 0.020 divided by 0.010, that's going to give me 2. The changes in 2. And then here, 2.3 times 10 to the minus 6 over 1.15 times 10 to the minus 6. This will give me, so for H2, I'm writing for H2O2. H2O2 is 2. And then, it's x to the second power, right? Because 2.3 divided by 1.15 will give you 2, and so x will equal 1. So H2O2 will be to the first power. All right, let's do something for iodine. For I, we need to find an H2O2 and an H that are constant. So automatically, let's do 1 and 3 work. 0.010, 0.010 for H, right? 0.something75, 0.something75. So we look at 1 and 3. So 0.020 divided by 0.010. This will give me 2. And then 2.3 times 10 to the minus 6 divided by 1.15 times 10 to the minus 6. Same thing like H2O2. 2.3 times 10 to the minus 6 divided by 1.15 times 10 to the minus 6. This will give me 2. Put an x up there. X will be to the first power. So first order. Alright, for H. You find an H2O2 and the I that are constant. So automatically I see 1 and 4 work. Right? because 0.010, 0.010, 0.010, 0.010. So you take this 0.1 divided by 0.something50. This will give you 2. And look, 1.15 times 10 to the minus 6 divided by 1.15 times 10 to the minus 6. That will give you 1. 2 to the x is equals 1. Anything to the 0th power will give you 1. So x will be to the 0 order. So cool. We have all of our orders down. That's A. So write the rate law. So it's going to be rate equals K. And notice how H is to the 0 power. You don't have to write H at all, right? Because it would be like H2O2, right, to the first order, right? So 1. Then it'll be I to the first order as well, because right, there's 1 right here. And it'll be H to the 0 power. Right, that works, right? But you don't have to write this H to the 0 power, because anything to the 0 power is just 1. So this whole equation wouldn't be changed at all. So we can just get rid of it. So that's B for you. C, determining the rate law, the rate constant for including units. So rate constant is just K. And the way we find K is by just plugging in any experiment into here. So let's just do number 1. Rate is 1.15 times 10 to the minus 6. Okay, right. H2O2, we can just use 0.01. 0.01. And then for I, it's just 0.01. Right, they're both to the 1 power, so it's nothing there. You don't change it at all. You divide both sides by 1, 2, 3, 4. Right, divide this side by 0.1, 2, 3, 1. K will give you, right. I also forgot to write the units, so this is M over S. This is just 0.01 M. It's the same thing, 0.01 M. So you have to divide it by M squared. Right, because M times M is M squared, and you have to divide it by M squared so you can isolate K. So M squared right here. Right, and so M over S all over M squared. This will give you M over M squared S. Right, and this will give you 1 over MS. So dividing this by that, you'll get 0.23 times 1 over MS. Cool. Let's go practice 43. Happy studying.